Hello?
Hello, Dr. Mohanta.
Am I audible to you, ma'am?
Yes, we can see you and hear you.
Good morning, esteemed panel members and intellectuals and presenters of this session. I am Jyotirmayee Mohanta, Assistant Professor, Department of Geography, Government Autonomous College, Fulbani, Odisha, India. Today, I am going to present the fuzzy regression model to assess the rainfall variability trend in Kalahandi, Odisha, leveraging 100 years of data for trend robustness and predictive accuracy. Could you please present the next slide, ma'am? This content, the Kalahandi district of Odisha, India, which is highly climatic variable due to its dependency on rain-fed agriculture and irregular monsoon patterns. The climate change has intensified this vulnerabilities through increased temperature and erratic uh, precipitation rhythm. So the projection indicates a 4 to 16% increase in rainfall across Odisha by mid-century, and the variability of monsoon system still threatens agricultural productivity and water resource stability. The traditional statistical techniques such as linear regression and man-cattle test have limitation in dealing with the non-statically and uncertain climate dataset. This method may oversimplify complex non-linear relationship and fail to quantify the epidemic uncertainty. The real-world dataset, especially the rainfall records in Kalahandi, are often improvised, incomplete, and inconsistent. In such context, the fuzzy set theory introduced by Zeta provide the mathematical framework to model imprecision and uncertainty. Fuzzy set theory has found wide application across the disciplines such as mathematics, economics, and computer science, all these things. And the study proposed a fuzzy regression model to analyze the century-long rainfall trends from 1923 to 2023 23 in Kalahandi districts, and the model integrates the fuzzy logic and regression to capture the vagueness of climatic data, offering a improvement over deterministic model and aroma of classical regression. Could you show the next slide, please, ma'am? And these are the objectives to identify. One is to identify the long-term trends in annual and seasonal rainfall, contextualizing the findings against the global climatic change projections, and quantify the uncertain in trends detection through the fuzzy regression parameters, addressing the gaps between the deterministic models. And third one is to access the linkage between rainfall variability and historical crop yield patterns, breeding, climatology, and agricultural planning. Could you show the next page, ma'am? Next one. This is the study area. The first map shows the India map, and second one is below that the Odisha map, where the district is situated. That is the map of Kandhamal districts. Next slide, ma'am. About the area, the location, and the situation. The Kalahandi is a western Odisha district, which is in eastern India, located between these latitudes, and this is surrounded by Bolangir, Nuapada, and Rayagada district as its relative location. And about the topography, the district has forest, hills, and plains, undulating hills, and residual silts. All these are there, and tropical climate is there, and experience hot summer and monsoon rains. And Indravati river adds in irrigation. In as per the census 2011, the population is around 1.57 millions, with a significant tribal population dominant, and mainly the language is spoken over there is Odia, and the tribal dominants are Kandha and Sourad Kandha. The economy of that area is mainly agrarian, with paddy, as the main crop, and supplemented by mixture forests such as small scale and industries. And talking about the developmental context of that area, despite natural resources, the Kalahandi faces developmental challenges like drought, fraud, food insecurity, making it a key area of rural and tribal studies. Next slide, ma'am. Next slide. This is fuzzy set identified defined by A as a offset universal set omega. In A, each function x is associated with membership function mu lies between 0 to 1, and the equation 2 is a triangular fuzzy set number is defined here, and the membership function of triangular fuzzy number is defined in this equation 2. Next slide, ma'am. In equation 3, the arithmetic properties of the triangular fuzzy set number are given, and in definition of arithmetic properties are given here. And the fourth one is the expected value of the triangular fuzzy number given in the which is defined in the equation 3. This is the 4G regression model, where the regression analysis is a statistical method to use model and analyze the relationship between dependent, which is response variable, and one or more independent, or the predictor variable. It is primarily used for predicting the value of dependent variable and understanding how the change in the independent variable affects the variable. The most commonly used form linear regression, which describe the relationship using a straight line equation, and widely applied in economics, engineering, medicine, and social science. And the model is given here, where y is equal to beta 0 plus beta 1x, and this is the equation where y is the dependent variable and x is the independent variable, and beta 0 is the intercept, and beta 1 is the slope of the regression line. And this is the coefficient of beta 0 and beta 1, and estimated by minimizing the sum of squared residual. This is the equation. Next slide, ma'am. The input and output are presented in triangular fuzzy number here, and the middle, where the lower, middle, and upper value of fuzzy input is given here respectively. And the fuzzy linear regression equation is given here below that, and the model decomposed into three classical linear regression equation. These are presented here, and then the parameters are estimated by the minimizing square head error, and these are given below that, and that then the regression coefficient are obtained by using the given equation. And for the prediction, for the new input, or for prediction, the following equation is used. Next slide, ma'am. Next slide. This is the statistical description of the rainfall data, which is obtained for the year from the year 1923 to 2023. And next slide, ma'am. Next slide, ma'am. The annual rainfall data of the past 100 years from 1923 to 2023 of rainfall data is of Kalahandi district, and Odisha was model using triangular fuzzy number to account for uncertainty and imprecision in the historical data set. And the fuzzy linear regression analysis was used to model the rainfall trend. The model estimates where obtained by solving these the separate least square problems for the lower, middle, and upper bounds of the triangular fuzzy data. And this is the equation. These are the equations, and the fuzzy regression model for the future rainfall prediction is given in equation 6, 7, and 8. Next slide, ma'am.
Sorry, ma'am.
Fuzzy
Sorry for interrupting you. Okay,
yes,
you
ma'am.
have 1 minute more. Please
Okay,
conclude
ma'am.
and
Okay,
summarize your
okay, ma'am.
answer.
Please
Thank
come to the conclusion slide, ma'am. Next slide, ma'am. This is the regression model. This is the regression model. Next slide. This is the regression model where the ma'am, previous slide, please. 1 minute only. Previous slide, ma'am. I have only 1 minute. The middle. This is the result one. Next one. Next. Just next one. Next. Madam, next one. This one. The median value trend, the rainfall exhibits the gradual increase over the decades, indicating a possible overall rise in rainfall, and the lower bound trend showed a slower rate of increase compared to middle trend, reflecting the lower range of variability, and the upper bound trend displays the significant variability in the steeper increase, particularly influenced by the year of extreme rainfall. Next slide, ma'am. Conclusion one. And this is the conclusion of the study, where the certain uncertain on nature of rainfall data emphasize the unpredictability of the precipitation pattern, which is a critical hydrological planning for sustainable agricultural prediction in the Kalahandi region. And the fuzzy regression model provide a more flexible and realistic framework for predicting rainfall compared to traditional CRISP method, accommodating imprecise and uncertain data efficiency. The predicted fuzzy precipitation range for the year 2014 offers variable insights for pattern of policymaker, enabling development and robust strategies to mitigate the associated risk and rainfall variability, and significant variation between the lower and upper bound of the upper bound predicted rainfall in some years indicate heightened uncertainty on scoring the urgent need for the resilient water resource management. And the model delivers both deterministic prediction through the expected values and probabilistic insights by fuzzy bounds, supports the comprehensive risk benefit analysis. Further enhancements could include the validation and observed data, and integration of traditional climatic factors, and define forecast accurately. Next slide, ma'am.
Thank you very much, Ms. Mohanta. Thank
Yes,
you for
ma'am.
your
These
presentation.
are the reference, and thank you for your valuable time and patience.